for the privilege to extend my warm welcome to all present here. CHMS Society, Dr. Munje Institute of Management and Computer Studies, was established in 2002 in the memory of Dhanmavir Dr. Balakrishna Shivram Munje. DMI is a leading institute offering various post-graduation courses in management and computer studies like MBA and MCA. DMI is affiliated to Savitribai Phule Pune University and approved by AITCE, New Delhi. DMI is well known for the state-of-art infrastructure, healthy learning environment, and academic ambience with proactive academic leadership, experienced and dedicated research-oriented faculty, strong institute, industry interaction and collaboration. Every week in our institute, we organize Industry Samvaad, where renowned personalities of industry guide and motivate us. Industry Samvaad is a program which is helpful to bridge a gap between industry and academics. All students get opportunity to interact with renowned person from various sectors. Today, we have with us a very accomplished person, Mr. Jayant Kulkarni sir, from world topmost and renowned IT company, Google. I feel deeply honored to welcome you, sir, on behalf of DMI Nasik. Sir has completed Bachelor of Science in Microbiology from University of Mumbai, Masters in Computer Management from Pune University, and also a certificate degree in Data Science from USA. Currently, Sir is a cloud engineer in Google USA. Sir is an IT professional with 23 years of experience in various aspects of IT, like programming, system administration, data architecture, enterprise architecture, cloud computing, data warehousing, integration, and many more. Talking about work experience, sir, I've worked with Wonderman, Dell, Oracle, Wipro, and Fujitsu. Sir strongly believes in teamwork, mutual respect, providing value, working smart, and perfection in his work. Sir is a problem solver who loves challenges. Sir believes in spirituality, believe that along with the experiencing the outer world, one should experience the inner world as well. Sir believes that this inner journey will help humans to becoming more accepting, forgiving, and ultimately in attaining peace and happiness. Sir, we are fortunate to connect with you. On behalf of DMI, I welcome you, sir. Now, I request Mr. Jayant Kulkarni, sir, to please take over the charge and guide us. Thank you.
Thank you. Thank you for the introduction, Neha. Appreciate it.
Thank you, sir.
Let me just start by sharing. Give me a sec here. Let me know if you're able to see my screen. Just give it a second to come up.
Yes, sir, it is.
Perfect.
Yes, sir.
I will be looking here and there a little bit because I have two screens that I'm going to share this on. I hope you're seeing the right screen. I'm sharing the cloud computing trends and careers. Is that
Yes,
what
sir.
you're seeing?
Yes, sir. Yes, sir.
Perfect. On the bottom left corner, you will see my name and my email address. So I have promised Professor Rasar that I'll try to address as many questions as we can today. But if I cannot, then please note down the email that's out there, and I'll be happy to take any questions offline. And as and how I get time, I'll address those. But I'll definitely address those questions that you have. Okay. So let's go ahead and get started on today's topic. I was told I have 1 hour, out of which I think I have 45 minutes or maybe 30 minutes to do the presentation. So I'll try to keep it timed as much as possible. I get geeked out when I talk about cloud and topics that relate to technology. So bear with me if I do that. Okay. So today's topic is cloud computing, trends and careers in it. Before we start, what I would like to do is give you a little bit of a disclaimer that these views expressed in this session and the material are purely of those mine, and in no way they reflect any thoughts from Google or Alphabet companies. And this is the agenda for today. We already did the introduction. We will look at a little bit of history of cloud. What are the trends in cloud computing? What are the careers in cloud computing? A few tidbits for success that I have learned through my experience, the short experience that I have. And then finally, we'll conclude it with question and answer session. Introductions, I was already introduced a while back, but this is my introduction. I'll skip this slide. Before we start, let's pray for all the beautiful souls that we have lost to this pandemic and pray that God gives us all strength to overcome this adversity. And now, before we hop onto the main topic of careers and all those things, let's take a quick summary of the history of cloud computing. So industries, why are we here is the first thing, right? Why are we having this conversation? There are two main things that we have to look for when we have to make a career choice in any space. And that is, number one is industry trend, and number two is the skills that are required, right? Industry trend, because if the skills you're pursuing are not in trend today, then how can you find a career in it? That's the question, right? And skills required, because your skills should align with the industry demand. And today, there's a huge gap in what the industry is heading towards and the skills that are out there in the market. So let's take a look at this slide. There are two charts that are represented here. The topmost is a donut chart, which shows over 90% of enterprises have adopted cloud computing in some shape or form, which means that whether you like it or not, or whether you want it or not, you will end up working in one of them, and you will be on cloud computing. The remaining fewer than 10% enterprises that have yet to adopt cloud computing, or they don't plan to, they will have no other choice but to adopt it. Otherwise, they have the risk of not being able to survive this market. And another factor we see in this cloud computing is the spend, right? So if you see the bottom chart, which is a stacked bar chart, it shows this cloud spending and the trend that it is seeing. And as you can see, it's an upward trend. By 2022, we will see that the cloud spend has jumped to $362 billion from $305 billion in 2021. And this has been an upward trajectory, and it will always be like that for some time. Not just because enterprises are adopting cloud for hosting their IT infrastructure, but also for their survival to make informed and timely decisions using technologies like artificial intelligence, machine learning, high performance computes and all, which require a lot of computational resources on demand and at scale. Okay. The next chart we are going to see is basically a cloud maturity index across industry verticals. And as you can see there, cloud adoption is across all industries, with some like healthcare, which are just getting in, while others like finance can be considered as expert. If you see finance is showing as 60% expertise. Overall, a huge opportunity in cloud computing across any industry. So whether we have industries which are coming in as newcomers or industries which are experts and have already adopted it, there is cloud computing in every aspect of the industry. And the second table below that shows the trends that are set to impact the business growth positively or negatively up to 2022. And if you see, I have highlighted in red bracket there or box there, the top 5 are in technology, and all of them will be in cloud, whether we like it or not. The next conversation that we are going to have around is the skills, right? So earlier we saw the trends, and now the skills. So this skills is the second part of the equation. We are in another disruptive phase of economics, just like we were in the industrial age, right? Today too, some jobs will lost to automation, and many more will be created in return. If you see the stacked bar chart that I've shown on the right top corner, you'll see that there are about 75 million jobs that will be lost to automation, but then jobs generated due to automation are almost 133 million. So God closes one door, but opens many more. And there is a huge gap between the skills that are required by the industry and the skills that are out there. It is taking sometimes months to fill in a position in cloud computing. So for example, we are also seeing this trend. We're seeing anywhere between 3 to 5 months to fill up some critical cloud computing positions because of the gap in the skills that we are seeing in the market. We have people who want to interview with us, but just because we don't have the skills that we are looking for, that poses a big problem. But if you see both the parts of the equations, right, the industry trend and the skills, the odds are all in your favor from an industry trend perspective. Now you just have to make sure that your skills align with this trend so that you are able to pursue your career in cloud computing. Now, let's take a look at the quick history of cloud computing, right? So this doesn't go very far back. If you see, 1994 is not very far back. I was born way before 1994. That means I'm a little old. But if you see, in 1994, General Magic used cloud computing. Compaq used it too. This was more from a physical aspect, but the conceptual aspect of cloud computing was there, I think, in 1960s also. There were rumbles and talks about cloud computing at that time, but because the capabilities did not exist and there was not a reason for adoption, it was in the conceptual phase only. It was not in physical phase. And if you see on this trend line here, you'll see that 1994 General Magic, 1996 Compaq, 2002 Amazon Web Services. I think Amazon is the one which pioneered the cloud computing strategy or cloud computing technology. And this was more from a necessity perspective. If you know the history of Amazon, Amazon was into e-commerce and all. And one of the things of e-commerce business is that e-commerce is cyclical in nature, which means they did not have a lot of requirement for compute powers for the entire year, but 2 months of the year, Thanksgiving and Christmas time, they had a ton of requirement. People jumped in and they wanted to buy things. And they were forced to purchase hardware with thousands of processors and storage. Now, that allowed them to do their business for the 2 months that they had the necessity to do so. But then for 10 months, their hardware just sat in the data centers doing nothing. So they had to come up with a smart idea on how do I capitalize on this investment that we have already sunk into these servers. And that's how AWS was born, where they started to rent out the computing and the storage aspect of their data centers. After that, if you see 2006, Amazon again pioneered the S3 and EC2. I think before 2006, they were in SQS and all those services, but not on the compute and the storage that they introduced in 2006. Google forayed into cloud computing in around 2008 using App Engine, which was the first of its kind platform as a service offering. And then after that, 2010, Azure plus OpenStack, and then 2011 onwards, we see IBM, Oracle, Google introduced its infrastructure as a service, and so on and so forth. And now we see that cloud has evolved much more beyond that. So why cloud, right? I mean, that's the obvious question. Well, obviously, there are quite a few reasons why cloud is being adopted, and it's very popular across all industries. Operational expenditure versus capital expenditure is one of the foremost things, right? So you don't have to sink your costs in and spend money into buying servers and data centers and all. You can operationalize that. You only pay for what you do. So this is basically the difference between owning the house and renting a house. Rapid provisioning is another thing where I remember times when I had to install a database, I had to make a requisition, and it took between I put the requisition to me to get the server for installing a database and installing the database and handing it over to the application teams about a month or so. That's a long time. Today's market, you cannot survive that. You need to have a faster time to market. And rapid provisioning is obviously one of those things. You can spin up a server in less than, I would say, 30 seconds on Google Cloud. Reliability is another reason why industries are adopting cloud. Scalability obviously is there. There is a huge demand for scalable infrastructure. If you have user traffic coming in, hundreds of thousands of them, you should be able to scale. You cannot do that in a traditional data center. Faster time to market, we spoke about that a while back. Cost reduction is obviously there. Cost reduction from a perspective of you don't have to be the owner of a data center. You don't want to invest into that. You don't have to pay for the security, heating and cooling and all those things. It's all being taken care of by the cloud service providers, right? Agility is another reason why you need to have cloud computing. Elasticity is one of those, which means you can elastically scale up your infrastructure and scale it down when you don't need it. And then you only pay for what you use, and what you scale down is what you don't pay for. Obviously, cloud is global in nature. There are 30 plus regions where Google is present across the globe, and we are growing. Competitive edge is another one. It allows you to move faster than competitors, fail fast and innovate rapidly. Unlimited resources, virtually limitless processors and storage is another aspect of it. efficiency via automation. You don't have to worry about managing the operating system, patching it, upgrading it, and managing any of the other stack in IT that we see, right? Uh, and there are many more other reasons why adoption of cloud is there. So next slide talks about the different service models that we have in cloud computing. As you go from the left to the right, you give up on managing some of or all of the layers of the IT stack, which then enables you to focus more on innovation and working towards your organization's bottom line. If you see any organization, IT is considered to be a cost center. What happens is you are not into the business of profit making. So whenever there are layoffs and all going on in any industry, the first place where they put the axe on is in the IT department, because IT does not contribute to the profit. That, however, is changing with cloud computing. What is happening is now your IT is not spending time on traditionally managing, installing, upgrading, patching, and all those things, but they're focusing purely on writing code that brings value to the table. All right, to the fun part, let's get into the trends in cloud computing. All right, so there are quite a few trends in cloud computing, and I tried to capture as few as I could possibly do, and the ones which I think are more important, where I see it with my customers and other people that I talk to. So cloud computing started with organizations adopting a single cloud provider, primarily using the infrastructure as a service. However, what has happened over the time is not all cloud providers can provide everything, and some have offerings that are very unique to just them, right? So obviously, customers have no other option but to go and find other clouds. By doing so, what has happened is it has created silos of multiple clouds, and customers have no choice but to adopt what we call as hybrid multi-cloud strategy. Hybrid multi-cloud means you have invested in your data centers. Maybe you have a lease for the next 11, 12, 15 years, whatever time frame you have committed to. So you have assets in your data center. You have assets in, say, for example, Google Cloud. You have some assets in Azure Cloud and AWS Cloud. And these all have to be worked together. And that's what this strategy means, hybrid and multi-cloud. And because of all these reasons that we spoke about, this is one of the foremost thing that we are seeing with any customer, that they are into many clouds and they are into data centers as well. And they have to make their organization work across all these different resources. So the next obvious question is, how do we tie all these resources together, right? So like we saw earlier, hybrid multi-cloud is inevitable, and that brings us to another trend that we see in the industry, and that is networking and security. And this is a very, very strong place where you can position yourself if you want to be in this space, because for any organization to succeed, you have to have network integration and you have to have security. So how do these organizations connect these various resources across on-premise and various cloud providers, right? How do organizations secure these resources, yet make them available to everyone? We talk about democratization of data and all. That is not possible unless you are able to tie all these pieces together. What about performance metrics like latency, throughput, egress, and all those things, right? What if you have to build a distributed cloud? These are, again, another set of trends that I'm talking about. A data fabric, this is another cloud trend that we are seeing. What about implementing a block cloud? We'll talk about that in the next few slides too. Without a strong networking and security strategy, all this is not going to be possible. And the organizations are going to set themselves for failure by creating impenetrable silos. The other trend we are seeing is cloud agnosticism, as we call it. Increasingly, organizations want to design cloud agnostic applications for several reasons, right? Financial is one of those. Having the capability to negotiate with the vendors, not being held hostage into one specific cloud, ease of migration to any other cloud, right? High availability is another one. Spin up applications in any cloud in case the one which you are on goes down. And there are many more reasons for that. Organizations have to be careful when adopting the cloud agnostic strategy, though, because you know what happens when you do so? You put more responsibility on your IT team for managing and maintaining various layers of this IT stack, which then takes away the time that you could have spent in contributing to the bottom lines of your organization's activity, right? So that's the trend we are seeing, cloud agnosticism. Technologies like containers, Kubernetes, using open source like Python, MySQL, and all. And that takes us to the next topic, which basically is open source, right? So cloud agnostic architectures bring us to open source technologies, which form a very small subset of your cloud agnostic strategy. An open source cloud is any cloud service or solution that is built using open source software and technologies like Linux, Kubernetes, Python, and all that we spoke about. And like mentioned earlier, open source technologies are a subset, but an important piece of the cloud agnostic architecture that we spoke about. Let's go to the next trend which we have, and this is a very powerful trend right now. From one of an estimate, there are around 35 billion IoT devices. IoT stands for Internet of Things worldwide, right? Consider this number for a short time. 35 billion, that's a huge number, and that number is growing. Your Fitbit watch, your Apple watch, your sensors and all, everything is going to be Internet of Things. Your cameras, your doorbells, you name it and you have it. Your phones are themselves IoT devices. And these are going to generate a huge amount of data. And when I say huge, how does 73.1 zettabyte sound like? That's the number we are expecting to see by 2025. For your information, zettabyte, I'll show you in the next, it's about 21 zeros on top of 73. That's the huge number. And not all these devices have internet connectivity 24/7, which means that there will be a pause in making decisions, right? So to circumvent that, we need to bring these cloud technologies to something we call as edge, which means closer to these Internet of Things devices, where decisions can be made even though there is no connection to the internet. And this is what edge computing does. It solves that problem by bringing cloud to the edge, closer to the IoT devices. The next trend that we see is called continuous intelligence. So today's cutthroat competition requires that organizations make decisions in a snap, and on that, on the most recent data that they have, right? So, for example, if you're in a hospital situation and you are tied up, your patients are tied up to say machines that monitor their health, this data has to go in real time to the AI to be able to make decisions whether someone has to intervene into that. This is a life and death situation. So that's how important these things are. And depending upon the industry, you can get a trickle of the data or a deluge of data. And that's where I showed this picture of this little girl getting sprayed by a fire hose. Just to give you an example from one estimate, we spoke about that, right? 35 billion IoT devices worldwide, the amount of data generated by IoT devices to 73.1 zettabytes by 2025. Imagine this much amount of data coming to you and you having to make decisions on that data in near real time and acting on it as quickly as you can. That's the power of this trend. AI, ML, I don't have to talk anything about this because everything that you do today, your phones, your cell phones, if you have used Gmail and all, we have predictive typing, right? Have you started typing on an email and have you seen Google complete the next word, next two words, even the next entire sentence for you, right? That's the one thing. Google Lens, when I don't even go out and if I see an animal and all, and I want to know what that animal is, I can just point the Google Lens, the camera, my phone's camera, and ask Google Lens to tell what that is, right? And Google Lens can tell me accurately all the information that I need from it. So a lot of activity going on. So by 2025, the global market value of AI is estimated to surpass about 89 billion annually, meaning that organizations that don't embrace this trend will find themselves lagging behind their competition. Businesses must justify how their AI models arrive at their decisions. That's the explainable AI, right? How did your model come to a specific decisions? People want to know what's behind all this. Application leaders must make these models more interpretable and explainable. And the third is the ethical AI. This is a huge thing that's going on right now. Because AI has such a profound effect on humanity, AI developers are representatives of the future of humanity and thus have an ethical obligation to be transparent in their effort. Why did my AI make this decision? Is the decision being made ethical? Is there a bias into that? So a lot of things that are being considered in this field. It's a growing field, a lot of opportunities in there, but very important aspect of any artificial intelligence and machine learning. The next piece we have is something called as serverless. Organizations don't want to spend time in provisioning, managing, and doing any other things on the infrastructure like we spoke earlier, right? They want to have capabilities where they want to go in, write the code, do the business and be done. So that's another trend we are seeing. And a lot of cloud providers are coming out with technologies that are serverless. Google, for example, is coming up, has App Engine standard or functions or Cloud Run. You must be familiar with AWS Lambda also. Google BigQuery is another pioneer in what we call serverless computing. It's a serverless data lakehouse concept. What happens in that case is all you do is write your query. You don't worry about the storage. You don't worry about how that data is given to you. Behind the scenes, BigQuery will spin up hundreds of thousands of servers to act upon that query, read the data from the storage, manipulate and sort and do whatever it wants to do on it and present it back to you, all without you even having to consider designing a server or asking how many processors it should have and all those nitty-gritty details. Cloud PubSub is another one of those. Cloud Dataflow is another one of those serverless technologies. I know a lot of people have raised their hands, but if you are okay, let me just go through this session. And then at the end of the question and answer session, let's address those questions if you don't mind. Because if we spend time on addressing questions right now, what's going to end up happening then, I won't be able to cover all these things. And I'm just talking about the trends right now, but there are tidbits about the careers and all after these slides too. So this brings us to another trend that is very happening right now in the industry, sustainability, right? For the last 100 or so years, we humanity focus purely on industrial and technological progress. And we have come pretty far because of that. However, what we have done is we have neglected Mother Earth and are now only coming to that realization, right? What kind of planet we are, global warming and all those things. But like I said, it's better late than never. Organizations and consumers both are having this question to themselves. What kind of planet do we want to live on, and what legacy are we leaving behind for our future generation? Sustainability has gone from being an obscure concept in the back office to being a very tangible one, and organizations are being held accountable for sustainability operations right now. Google is no different, as you can see from these numbers that are on the slides. And Google is committed to being the leader in this space. So 90% of the waste is diverted from landfills. We don't put a lot of stuff in the landfills. 50% less energy consumption than an average data center is what we use. 100% renewable energy for all cloud regions. That's another thing that we have. Google is also going to be carbon free, or at least that's the goal or aspiration that we have. To go completely carbon free 24/7 at all our data centers by year 2030. And then Google has a power usage effectiveness or PUE score of 1.1. For your information, PUE basically is how much amount of power does your entire data center operation needs divided by the total power that your computing resources consume. So for example, let's say your entire data center requires 100 megawatts of power, and you're using 20,000 megawatts out of that for cooling, heating, and other things. But 80,000 megawatts of it is being used to actually run the compute processing power. That comes to about 100,000 divided by 80,000, 1.25 is the PUE score. Google is at 1.1 right now. The lowest score that can go on PUE is 1, which means out of 100,000 megawatts of energy that you have given to your data center, all 100,000 is being used purely for your computational purposes, nothing for cooling, heating, and all that stuff. And there are some of these data centers, like Google has some, I think Microsoft also has some, where we have data centers that are submerged in deep oceans under lower temperatures. And in that case, we don't need to have electricity diverted to cool down these data centers. They are cooled down by the environment themselves. And another aspect of this I want to show is the graph that is on the bottom right corner of the screen. it basically shows how we are tackling this problem, right? Sustainability. This is just one example of that. So we have implemented machine learning algorithms in our heating and cooling systems in the data centers. And as you can see, this test basically shows without the machine learning algorithm enabled, your power consumption is pretty high. The moment we turn the ML control on, your power consumption goes down almost 40%. And then the moment we turn the control off, your power consumption goes back up again. But we keep this on, and that's why we have almost 40% savings on our PUE. All right, the next concept is more near and dear to my heart because I specialize in the data and analytics space. The concept called as data lake houses. So traditionally what we had was data lakes, which was a concept for unstructured data, and data warehouses, which was a concept for structured data. The new area that we are seeing this is the merger or blurring of the boundaries between the data lake and the data warehouse. There is no longer a separate entity for your unstructured data and separate entity for structured data. Google BigQuery is one of those great examples of how these data lakes and data warehouses can be merged. Imagine data lakes having one set of data, you have to do ETL, transform that data, move into data warehouses. Now you have two sets of data. By doing so, you have also done some transformations, and data scientists say transformations, they want to act on the raw data. So all these good concepts are coming together and making one single uniform place where your data can reside without being duplicated, and in its most raw form that data scientists and your analytical teams can act upon. The next trend is basically block cloud, right? So security and reliability are important aspect of any cloud, like we spoke about earlier. But with so many different players and data scattered across various clouds, how do you secure and make sure that your data is tamper-proof, right? That's the important aspect of it, secure and tamper-proof. So many CIOs expect that blockchain will fundamentally alter the cloud industry by offering information, something called as information permanence, a guarantee that the current cloud capabilities cannot make. So for your information, I mean, at Bitcoin and Ethereum, I think you must have heard the names about all those things. It's not, I think, yes, you have heard names. But that's the financial aspect of the blockchain. Blockchain has many other aspects. And one of these aspects that Blockcloud tackles is, how do I take this data from all these various clouds and make sure that it is not tampered, it is secure. And the way you do that is then you scatter that data across different clouds, a single data set, and then try to encrypt it in different clouds. At the same time, blockchain it so that if anyone tries to tamper with that data, you know that the hash is going to change and that data has been tampered with. And by the way, even if it is tampered, that data is kept in various other places, multiple copies, so that you can always retrieve and restore it back. And needless to say, performance and all are also an aspect of that, because the more distributed your data is, the faster your access to that becomes. Okay, let's hop on to the next trend, cloud native applications, right? So cloud native applications are applications that are born in the cloud, right? They are not just reworked to be compatible in the cloud. These applications run on cloud infrastructure as opposed to being installed on an OS or a server in your data center, which means that instead of demanding compatibility, cloud native applications can dictate their environment by interacting directly via APIs. This is like end-to-end application development lifecycle using your microservices, your DevOps, your CI/CD, your containerization, and all those things. And again, there are many more trends that we can talk about. A few of them we spoke about earlier, a few of them which we haven't, but application mobility is one of those. Workstation as a service, so you won't have to carry your computers to your offices and all. If you implement workstation as a service, you get a Windows or a Mac or whatever instance you have carved out from the cloud, and all you have to do is then have a dumb terminal, which you can connect directly to that and be able to work. A lot of important aspects of workstation as a service. Number one, my hard disk crashed and I lost all my data is not going to happen there. Security, companies are increasingly concerned about people copying data onto their laptops or onto their thumb drives and all. and compromising the data. Workstation as a service eliminates all those problems. Distributed cloud is another aspect of it. Software as a service, platform as a service, cloud automation, containerization, cloud coalitions. I think this is important because what's happening is in earlier days, cloud companies were working in silos. They were all doing their own little things, and customers were on that. But cloud coalitions will give you ability to partner with other cloud providers. It gives an ability to partner with not just cloud providers, but also independent software vendors like MongoDBs, Databricks, and Oracle, and many others. What if these are able to come under a single platform and be able to operate across any cloud without any problems? That's what cloud coalition is. And that's where a lot of cloud providers are going. Google is already a pioneer in that space because Google allows you to run SAP, Databricks, Mongoose, doesn't matter which one it is. We have partnered with pretty much every single partner that's out there, every single independent software vendor that's out there. And we are able to run their applications, databases, whatever it is on our cloud without any problems. Human cloud is another aspect of it. Companies are increasingly wanting to have people or human resources for doing their jobs, but they don't have the ability to reach out to humans. Human cloud gives that ability where they can tie up people who are required individuals to work on and individuals who are looking for work together into one single place. You do your work right there and then and be done. Data fabric is another one of those aspects. So many good things that are happening in this in the cloud computing area, and there are many which we have not covered, but I'll be happy to address. If you know anything that's not out here, that gives me an opportunity to learn too. All right, now the stuff that you all were looking for, right? So what are the careers in cloud computing? So I like to put things into perspective from a hierarchical perspective, right? So cloud computing, you can have jobs in two different areas, technology and non-technology areas, right? Under technology, you can be a user or adopter of that technology. So for example, you can be an application developer, you can be a data scientist, you can be a security engineer, enterprise architect, CTO, CISO, whatever else it is. But you are basically a consumer of that technology. And the other one is a contributor, right? So product development is obviously a part of it, product management, cloud sales, which I'm in, for cloud companies. And in the non-technology side, you can be associated with that career path, which is direct, for example, cloud sales, cloud marketing and all in technology companies, or you can be in an indirect cadre where you are in accounting, finance, HR. You could be a CEO, COO, CMO, CFO, etc. in any industry, and you would have that career in the indirect aspect. As far as the roles go or the titles go, there are so many titles. I mean, it's just, I just couldn't grasp all of those and put it out here. But if you can see security engineers, CIOs, networking engineer, application developers, cloud sales manager, data engineer, data wranglers, enterprise architects, cloud sales engineer, cloud product engineer, solutions architect. These are just some of the job roles and titles. But there are so many out there that are not shown here. And if you think about it, you know, any job you do in the future is going, whether it's in tech or non-tech, right? It doesn't matter where it is. It is going to be using cloud technology in some shape or form, and you will be associated with cloud computing. A few tidbits for success. Again, a skill is not just a technical or an educational in nature, right? So a skill is basically twofolds. It is the IQ and the EQ. And gone are the days when companies used to purely look for IQ alone. So I remember interviews where I used to go and they used to just barrage me with technical questions. And nobody cared about what I thought, what my beliefs were, whether I was a jerk or not, or whatever else it is. But it was purely technical in nature. And once I passed all those check boxes, I was hired. That's not happening anymore. Companies are emphasizing on having both IQ and EQ. And I would say that the weight is leaning more towards EQ nowadays, emotional quotient, so that both of these are important in finding a job. And there are certain do's and don'ts that I have put out here. So certification in the do side, definitely get certified, because that tells that you are skilled into the latest and greatest technologies that are out there. Universities, colleges are good, but what happens with universities and colleges is, and this is not a shortcoming of that industry, it's just a big wheel that we have to spin. I remember my time when I was doing my master's. I was learning Informix and DBase 3 plus. And when I went into the market, there was no Informix and no DBase 3 plus. So I had to get trained in databases like in Oracle. I had to get trained on databases like SQL Server, on Sybase IQ, and all those things which were there at that time. So certification gives you that ability to learn and be certified in the latest and greatest technologies. Whereas colleges gives you the degree, plus it gives you the ability to be able to do the work and come up to the speed on these technologies. Any questions, Sheetal? Okay. So adapting fast is another of those things, right? If you see a technology out there, you need to be able to learn it and adapt to it really fast. Without that, it's not going to be a success. Continuous learning is another aspect of the do's. Challenging the status quo. Why are things the way they are? Can they be a little different? Is what this means. Respect is obviously out there on the top, because if you don't respect others, others don't respect you. And I have seen, without respect, team spirits get degraded and the team does not deliver. And organizations don't like that approach. Compassion is another one, right? Be compassionate. See if you're a cultural fit. What that means is, the company that I'm going to join, does it have the same principles that I have? Do I align with it? This is just like a marriage, right? You would not marry a person who does not align with your principles. Otherwise, you're going to have a miserable rest of your life. And that is true with the job market also. Do not try to join a company just looking at the salary, but it's not a good cultural fit for you. You do not agree with its principle. You are going to be miserable in that workspace and you are going to quit. Innovate is another one which you should do. Think outside the box. Why are things the way they are, and change the status quo. Contribute to the profit. Look for things that are profitable to the company. Don't go and do things like patching and upgrading and all those things. Those are non-profit making areas. Think about implementing AI models. Think about, how do I write applications so that it increases a profitability of the customer, of the company. How do I write applications that will improve customer satisfaction, so on and so forth. So contribute to the profit-making areas. Be humble, and always lead with a why. This is the major thing that I always lead with. I don't go in and do work just because someone told me to do it. I need to know why I am doing the work, because if I don't get that aspect, I don't do a good job of doing it. Without a why, you're basically doing the work for the sake of it, and that's not going to take you any further. Enjoying life, obviously, yes, that's on the top of the list, because you just have one life. Don't waste it. Help others. That's a very important aspect, because if you help others, others are going to help you. It reciprocates. Keep 5 wives and 1 husband. Not literally, but if you had been taught in the management, I was taught the 5 W's, which are basically why, when, where, what, and who, and the 1 husband, which is how. Always keep that in your pocket. Without these, you are not going to succeed. And one of the things that I have learned over the past so many years is, there are quite a few times where I have to make a decision. And there are times when it becomes very difficult to make a decision. But if I narrow things down to just one single rule, and that rule is customer first, then the company, then the team, and then the self. Decision-making process becomes so simple that you don't have to worry about things at all. It just becomes a black and white thing at that time. Let's take, for example, one of those situations, right, where you want to do certain thing, but you're not sure whether you should do it or not. So the first question you ask yourself is this of any benefit to my customer? If the answer is yes, go ahead, do it. If it is not, then why am I doing this, right? Is this also beneficial for my company? So I can do certain things for the customer, but they may not be in the best interest of my company. If they are not, why am I doing this? You should not do it. Is it benefit for the team? Does it help the team? And then at the end, whether this benefits me. But this helps you make decision making really, really simple. And the don'ts obviously stick out pretty well, right? Don't be a jerk. Don't get comfortable. The moment you get comfortable, you stop learning. That's my observation. I have seen people who had worked and then they get comfortable doing what they are doing, and it just doesn't take them anywhere. It just when the layoffs happen, they are the first people to go. Don't get involved in office politics at all. Don't work hard at all. This is contrary to what you see. Work smarter. Don't work hard. Uh, Working hard does not take you anywhere. Don't be disrespectful. This is specifically true for all the MBA students. Don't manage, lead. There is a difference between being a manager and being a leader. Don't be a manager, be a leader. Don't procrastinate. Don't be irreplaceable. This is very important. This has been the motto of my life. You know what that means? If you are doing certain things and you are irreplaceable, that means you cannot grow. I used to be so good in certain things that I couldn't be replaced. And although that gave me a job guarantee, the problem was I stopped growing because I couldn't learn things that I wanted to learn just because my company wanted me to do exactly what I was doing, because everyone was happy that I was doing it and I was doing it the best I can, right? So don't be irreplaceable. I automated the hell out of that system and then just moved on, because that's what it is. If you see something uh, that is that has a potential for automation, do it so that you can grow. It obviously takes away your what you call job guarantee, but it gives you an opportunity to grow, and you will grow leaps and bounds if you follow that strategy. Don't be afraid of speaking up if your intentions are good. Never do that. I mean, if you think there is a certain way of doing things and you think it's right, you have good intentions behind that, please do so. Do not be a yes person, and don't be afraid of failures. And the next set of tidbits is basically what we spoke earlier, right? We only have one life, enjoy it to the fullest. And I see this a lot of times, but we try to compete with people, but the only person you need to be better than is the person you were yesterday. And that's all it needs for you to succeed. And again, thank you for giving me this opportunity and allowing me to be a part of this learning journey. As you all know, learning never ends. And that's the wrap up, and I'm ready for questions.
Hello, sir.
Hello, Sanket.
Sir, I would like to ask you a question.
Uh-huh.
Sir, most of the youth know about cloud computing in India, but why is India far behind than other countries as compared to cloud computing environment?
I think quite a few things, right? Like technology always gets implemented in the West first, and then it comes to India. The other thing is infrastructure and all guarantees, right? A lot of these cloud companies are just coming to India and building their data centers. So that's one of the aspects too. And India, and not just India, but every country has data residency rules and all. So unless you have a data center there, data residency becomes a problem. So there are many aspects of this, and India is catching up to all these things too.
Yes, sir.
Hello, sir. Good morning. Hello, sir. Good morning, sir. Good morning, sir.
Hello.
Sir, what is the difference in cloud computing and computing for mobile?
I think there is an echo, but if I heard your question right, what is the difference between cloud computing and computing for mobile, right?
Yes, sir, it was.
Okay, so cloud computing and mobile, cloud computing is the bigger picture of it. Mobile application development is a subset of that. You can do mobile application development in cloud. Cloud is the bigger picture. Mobile is a small subset of that.
Okay, sir.
Yes, feel free to tell if you are not satisfied with the answer. I mean, I would be happy to do some more research. I would not say that I'm the expert of everything, but I'll try my best and try to come up with answers that would be helpful.
So what is the difference between Google Cloud and AWS Cloud?
Just two different companies. I think cloud, what happens is cloud is a commodity, as we call. Someone invents something and someone follows that trend. AWS started with infrastructure as a service. Google went into infrastructure as a service. Google introduced platform as a service. AWS came with platform as a service. Other than the fact it belongs to two different companies, the concepts of cloud are pretty much the same.
Okay, sir.
They might have products which are different for each other. Like PubSub is only a Google product. BigQuery is only a Google product, but so is Kinesis, which is in AWS and all. But different products are in different. They pretty much do the same or similar things.
Okay, so does Google hire freshers?
Yes, in fact, we have internship programs and all too.
Okay, I thought only experienced persons they are hiring. So
No, it's everyone, right from fresh out of college or not out of college yet to highly experienced people.
Sir, then
I
what
see
are
there
the
are
qualities Google want to see in their freshers? Can you tell us?
those are the exact same qualities we spoke about right earlier. IQ plus EQ both. So Google has interview programs where they not just gauge you on your intellectual quotient, but also on your emotional quotient. There is a concept called as googliness in Google, which basically is how willing are you to help? How willing are you to step out of the box? How humble are you? How you respect others? And all those qualities that you cannot really train someone to do. This is something that you have to be.
Okay, sir. Thank you.
Mhm.
Sir, which are the platforms that we can use to show our skills so that companies like Google or any other multinational company can uh, take us as a fresher?
There are many skills, right? Number one, obviously focusing on your college education, getting a degree is there. But find your passion. What is your passion? Whether you are passionate about data, whether you're passionate about infrastructure, whether you're passionate about security, whether you're passionate about networking, whether you're passionate about artificial intelligence, machine learning, and all those things, whether you're passionate about blockchain, quantum computing. Find that passion and get some expertise in that and start the interview process. I think that's all is needed.
so do we have to learn any programming language or coding compulsory to get into Google?
Not necessary. You can be in what you call programming roles also. Administration is one of those. You don't need programming, or at least heavy programming if you're a network engineer or security engineer or an enterprise architect, for example.
Okay, so these are some questions from YouTube. Which Google certification should students start from?
So there is a basic, what you call foundational certification that you should do, at least to start with, and it gives you a good overview of the basics of Google Cloud. And then there are specializations depending upon whether you want to be in the data space or whether you want to be in the application development space, infrastructure, networking, security, and all those things. But again, that all boils down to what your interest is, right? Find out what you're passionate about and do that. Don't do what someone asks you to do. Do what you think is your passion. Now that we have seen the trends, and use those, because unless you're passionate about something, you're not going to do justice to that.
Okay, so what is software as a service and platform as a service?
So software as a service, and I'll take you back if you can still see my screen. So have you heard of Salesforce.com, Workday, ServiceNow? So those are all software as a service. And what happens in software as a service is, if you see, this is the traditional IT stack, right? Going from bottom to top, networking, storage, server hardware, operating system, virtualization, operating system, application runtime, data and applications, right? This is a typical stack. There could be plus and minuses in there. But in a software as a service, you basically do not manage any of the things in the stack. All you do is use that service, and everything is managed by the software vendor or the SaaS provider. Platform as a service, if you go from the bottom to the top stack, you don't have to worry about networking, storage, hardware, virtualization, operating system, and application runtime. However, you are responsible for your data and writing your applications. That's the platform as a service. And if you go to infrastructure, it's the same thing. You do not have to worry about networking, storage, hardware, virtualization, but you definitely have to worry about patching and upgrading your operating system, making sure your application runtime is there, your data is there, and application development is there. Does that help?
Okay, so here is another question. Where to start for study cloud computing as a beginner?
You can start in any space, right? For Google certifications, again, there are basic foundational certifications that you can do, and then there are expert level certifications that you can do. Start with the foundational level, which gives you a good overview of your of Google Cloud infrastructure. And although I work for Google, it doesn't have to be Google, because like you saw, multi-hybrid cloud is the norm. So even if you get certifications in Google, in AWS, in Azure, or any other cloud, that's a good start.
Sir, is certification compulsory for Google?
Yes, if not during the interview, at least getting inside, yes, you do need to be certified.
What if the certification is expired or it has validity of only 3 years and then I apply?
Well, you have to, it's better if you retake it, because cloud is so fluid, it's changing so rapidly, that if you don't have a certification which is current, then you are obviously out of touch with what's being offered today. And that's not a position that you want to be in,
I thought they don't validate such.
No, there is a recertification program too.
Okay. Other questions. So to manage this huge amount of unstructured data, scientists will play a major role.
Oh, is it scientist or data scientist?
Data scientist.
I think it's data scientist, but again, the specific set of people who would manage unstructured data is something I call data engineers. And what that job does is it manages your data aspect of it, your unstructured data, your structured data, your data models and all, your MDM, data governance and all those things.
Okay, so next
but
question.
Yeah, in essence, yes.
Okay. Which platforms are used for large-scale cloud computing?
Well, cloud computing in general, whether it's AWS, Google, or Azure, it is all used for large-scale computing, right? You can have something as small as 1 vCPU, or you can have something as huge as hundreds of thousands of CPUs, high-performance computes and all. You can have many, many, many machines.
Okay. So which simulation software is best for task scheduling?
Simulation software, I don't know the answer to that, sorry. I can write that question down. Task scheduling, can you emphasize on that?
Hello?
Yeah, I asked what, can you emphasize a little more on that question?
So there is a question from Sashikant Sharma in chat box. I don't know really about, I can't elaborate. Sorry.
Okay, so shoot me an email. Let me research some more and see if I can get that answer. Because there are two things that I heard here. One is simulation software and other one is scheduling. So schedulers, obviously there are some good number of schedulers that are out there, right from Google to third-party vendors also. And you can use any one of those. But simulation software, I don't have an answer to that.
Okay, sir. Sir, how students can be in touch with you? Are you on LinkedIn?
I am on LinkedIn, but I'm not going to share my LinkedIn here. And the reason is because I have my LinkedIn shared with my customers mostly.
Okay.
And that's going to be a problem. So what I have is, if you go to the first slide, and I'll share this slide with Professor Asar also.
Okay.
If you go, let me take you to the first slide. Bear with me. Or let me just put my email. give me a second. We can address the questions while I'm doing that.
Sir, are there such online platforms to show our programming or some logical skills so that we get chance to work for Google?
Yeah, there are quite a few of them. Let me go and find some of those out. I don't remember on top of my head, but yeah, there are some online platforms that you can use. I'm trying to think which ones they are. I know for AI, ML and all, but are you looking for that or application development and all?
Sir, application development.
Okay, let me find that out. Can you shoot me
Sure.
an email? I just flashed my screen, the first slide. And if you see on the bottom, I have not put the @ symbol because if this gets out anywhere, there are bots which can go and figure out what your email is. They can basically go and look at @ symbols and be able to pluck your emails out. But my email address is j.kulkarni.us@gmail.com.
Okay, so is Google your first company or you joined as a experienced person?
No, I joined as an experienced person. This is my most recent company.
Okay. Which programming language we have to learn for Google Cloud Computing?
Which programming language for cloud computing? Cloud computing is not a language-oriented thing. Cloud computing is a concept, right? It is how you do computing. Now, within cloud computing, you have an application development track that you can use, and then you can pretty much use any programming language that you like. For example, Java, Python, Go, PHP.
Okay, so friends, any more questions? Please enter in chat box.
Sir, you are to reach the online platforms.
Can you repeat that question?
Sir, online platforms you are going to tell.
Yeah, I don't have that right now, but shoot me an email. I'll do some research. I'll ask a few other people. My specialty is more into data analytics. So I cannot tell a whole lot about application development, but I'm sure there are platforms out there. And also tell me your intention on that. So what are you trying to accomplish when you say online platform? That way I can find answers that are more relevant to you as opposed to just throwing a platform at you.
Okay, sir, I'll mail it.
You got the email address, right?
Yes, sir.
Any more questions?
So there is question from YouTube. What is virtualization in cloud computing?
So cloud computing virtualization, typically what happens, and this is infrastructure as a service again. So when you install, when you have a data center, for example, Google Cloud Data Center, right? You install a machine, which is going to be pretty big machines. And then you just want to have one single processor out of that. What you have to do is you have to install virtualization on top of that. You have to create a virtual machine and then carve out that one single processor out from, say, for example, if it is a 32 processor box, and assign it to you. So this is like a computer within a computer.
Okay, so another question. As an expert cloud learner, in your opinion, who is future leader in cloud? Google or Amazon?
I'll say Google, definitely.
Okay.
No, but today, if you see, the top 3 clouds are AWS is first on Amazon Web Services because AWS had the head start, if you see, right? It came up much ahead of in the cloud computing before anyone else could. And it was because of the necessity that they had. Microsoft Azure is the second one and Google is the third one. But Google is the fastest growing cloud. I mean, it's growing very rapidly right now.
Okay. Does Google have any specific strategy for education and students with respect to cloud learning?
Absolutely. So Google has certification journeys. Number one, we spoke about that, right? All the different certifications. However, there are also certificate courses on Google Cloud platform. And if you shoot me an email of the person who has asked this question, maybe I can send the link also for that. Now, this may not go well with the college professors and the deans and all that are there on this call, but the future of job market, employers are increasingly looking to kind of not look at educational backgrounds and all in the future. And then the reason is because of the things we spoke about, right? It takes a lot of time for colleges to update their curriculum and bring the students up to the speed to the most latest and greatest trends that are going out there. And I gave you an example of how I was learning DBase 3+ and Informix when Oracle and Sybase and SQL Server were dominant in the market when I got on the job. So I had to spend like another 6 months just doing certifications in Oracle and all, just to get a job in Oracle. So yeah, it's certifications and then the certificate degrees of courses that are coming out from Google.
Okay, sir. Thank you. Good morning, everyone. It's my privilege to present the vote of thanks for today's lecture. I would like to thank our Honorable Mr. Jayant Kulkarni, sir, for guiding us on recent trends and career opportunities in cloud computing. Today's lecture was full of knowledge and interesting things. It gave deep insights into the topic and also revealed some interesting facts and enlightening us with the knowledge. I'm pretty sure this precious knowledge that sir gave us will definitely help us in studies and future. The guest lecture aimed to bridge the gap between study and practical exposure, and the students benefited from the knowledge of cloud computing concept. I am also thankful to the All Society official Dr. Ajit Bhandakar sir, guardian of DMI, Rahul Vaidya sir, chairman of DMI, and Dr. Preeti Kulkarni madam, director DMI, for always guiding us and motivating us. I would also thank Tanmay Dikshit sir for the technical support for the event. I am also thankful to all the staff members of DMI for organizing this webinar. I would like to thank all the participants for their huge response to this event. Thank you all. I now declare the event is over.
Thank you.
Thank you everyone for the opportunity. You guys have a good weekend.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you.